Okay. Welcome, everyone. My name is Mike Gualtieri. I'm a principal analyst with Forrester. I cover data analytics, but also how they get integrated with applications. So one of the things that we've been hearing a lot is terms like real-time analytics, streaming analytics, and so we evaluated a number of products in this space and a number of use cases. So what I'm going to talk to you about this afternoon is about what streaming analytics is, how you need to think about it, and why it's very, very different from regular old normal analytics. And there's something we call perishable insights, and these are insights that occur at a moment's notice. So you can't put that data in a data warehouse and then do some analytics on it later. You have to act on it right now. So in a nutshell, that's what we mean by perishable insights. There is some background I'm going to have to give you so that you kind of understand streaming. So you're going to have to bear with me. That'll go pretty quickly, but I have to, for those of you who aren't familiar with predictive analytics, I'm going to have to give you a little tutorial on that first. So that'll be fun. I did want to point out a few things when it comes to data. You can see here we surveyed a couple thousand IT executives, enterprise IT, and we asked them to rank in importance and investment, what their top objectives are. And you can see all the usual suspects there, including cloud, systems of record, mobile, social, right? That's understandable. But what's absolutely lovely is that data-related projects has risen to the top. Data is hot now, okay? And it's true that data runs through all of those things. But it's interesting that that is what enterprise IT is now saying is most interesting. The reason for that is there's a demand for analytics of all kinds, including streaming analytics, which we're going to talk about. And businesses often think of analytics as just a set of historical reports and dashboards. Most analytics, in fact, are a historical set of reports and dashboards, but it's also about the future. So it's also about using in-the-moment data streams and predicting what may happen and acting on that. So when we ask companies what sort of analytics they're interested in adopting, and you can see here we did a comparison between 2012 and 2014. Okay, you got reporting, you got dashboarding, web analytics, and all that sort of stuff, right? But look what's circled. So predictive analytics has a 52% increase between 2012 and 2014. That's a lot of momentum. Streaming analytics, 62% increase between 2012 and 2014. What's interesting about these statistics, though, is that only 21% of the companies report using streaming and 32% using predictive. So what I think you should be thinking about in your own application development and firms is that, wow, that's a pretty good opportunity for you because a lot of your competitors are not doing this. So it's still early times for both predictive and streaming analytics. So that's quite interesting. And when we did our wave, which is an evaluation of products in the market, we published that, and it was the second most read document at Forrester in Q3 out of 500 documents published. So that sort of validates the interest in this. Not sure why that slide's not showing, so I'll just go past it. We also asked companies to estimate what percentage of their data do they use for analytics, and it's probably no surprise it's only 12%. So there's a lot of opportunity for analytics of all types, not just streaming, but historical. And to understand streaming analytics, you have to understand a little bit about predictive analytics, because streaming analytics is about looking at what's happening now and determining what to do about it in the next few seconds, or in the case of algorithmic trading, the next few milliseconds. So this is sort of the background that I'm going to have to give those of you who aren't familiar with this. But basically what we're talking about when we talk about predictive analytics is data science, and that's about finding hidden new knowledge or predictive models that can take data as an input and then predict some occurrence. And when companies can predict outcomes to a certain probability, they can make a faster decision, or they can make a better decision in many cases. And one thing to understand is that predictive models are about probability. They're not about absolutes. So for example, there's a 78% chance you might like Breaking Bad. Or there's a 80% chance that a stock is going to go up. And predictive models may not exist for every question. Now, the reason you need to understand predictive analytics is because you can't do interesting streaming analytics without first creating a predictive model to put in the streaming engine. But when you can find a predictive model, it can be fabulous. And there's lots of businesses built on predictive analytics. I would say Netflix is one of them. Data scientists use a combination of statistical and machine learning algorithms, and that's how they actually find this. So when we're talking about predictive analytics, we're talking about offline analytics. Do not think that streaming analytics is some sort of magical thing where you just like connect all these data sources and somehow it knows what to do or it can find insights. It cannot. Streaming analytics platforms cannot find insights automatically. You first have to have a model. You have to tell it what to look for. So it's important to understand predictive analytics. Now, traditional analytics is very different from predictive analytics, and I think this will help you understand what we mean by predictive analytics. So say we're a large telecom and we wanted to predict what companies are going to churn. Okay, so you have a cell phone, wouldn't it be valuable, and the telecom's been doing this for ages. They determine what likelihood is someone going to go to a competitor. Okay, so how does that happen now with traditional analytics? Well, let's just say you're from the retail stores, you're from customer insights, you're from marketing, you're from R&D. There's a meeting that takes place at these companies, and everyone hypothesizes about why people might churn. Well, a competitor has a family plan. The prices went up. There's a new iPhone. Right? There's all kinds of hypotheses of why customers will churn. And then what do you do with those hypotheses? You give them to an analytics person who then creates a data model and then generates reports or a dashboard of all the customers that are likely to churn in the future. And then you give that to marketing, who then tries to figure out what to do about it. What can we offer them, or what can we say to them, or what can we not say to them so that they won't churn? So people think that that traditional analytics approach is a data-driven approach. It's not. That's a human-driven approach that uses data to support their hypotheses. Okay? Predictive analytics is very different. Predictive analytics, we don't really need the experts. What we need is as much data as possible. Transactions data, what phone numbers they call, every shred of data that we can get, and then we run machine learning algorithms against that data. And if we're lucky, we will find some sort of a predictive model. Notice that we didn't have experts involved. Okay? That's because the data, the algorithms are looking in the data for what data matters, what correlates to the likelihood of churn. Okay? So it's very, very different. When you're doing streaming analytics, both of these approaches work. Sometimes you know what you're looking for. So for example, streaming analytics was often called in the past CEP, complex event processing. And complex event processing made its way onto Wall Street because you had a trader who had an idea about if this stock goes down and this stock goes up within 1 minute, then buy or sell, right? And in a $300,000 a year C++ programmer sat next to that trader and coded that up into like a mini custom streaming application called CEP. So that was definitely a human-driven approach, and that's still valid. There's many cases where that's valid. But you also, especially in the era of big data, might want to use a predictive model, a model that determines what the likelihood of the outcome is that you can then insert in the streaming model. So that's why it's important to understand predictive analytics. So let's think about how that might work in the case, in a real example. Spotify, or Pandora for that matter, right? They stream well, okay, different streaming, right? We're talking about streaming analytics versus streaming media. I hope none of you are here for streaming media. It's very different. So if you think about where people listen to Pandora and Spotify, I talked to Pandora and they said about 60% of people are now listening from some mobile device. Well, a data scientist might think, okay, what sort of sensors do we have on that device we can use? I guess location's obvious, right? You have time of day, you have potentially weather from other streams, but there's also an accelerometer. So imagine that you could collect the accelerometer data from that, and imagine, just like the now defunct Nike Fuel Band, you can detect that they're running, and you can detect the tempo of their running. You can collect all of that data, create a predictive model about what that listener is doing. Are they running? Are they dancing? And maybe predict the certain joyfulness of the song, for example, a characteristic. But that's a whole lot of data you have to gather. Then, so now we've created a model that detects, okay, Mike, when he runs, he doesn't want to listen to Led Zeppelin, he wants to listen to Lady Gaga, right? Because it matches the tempo of my run, perhaps, maybe a slower Lady Gaga song. We created that predictive model offline. Now we take it and we stick it in the streaming platform. And now, as I'm running and it's collecting all that data, it's detecting that I'm running. Okay, but it might have to detect that. It might take 5 seconds or 10 seconds for it to detect that. There's not just one motion that's going to detect it. Okay, so that's a clear example of where you do offline analytics and then insert it into a streaming model. So part of the reason why we're talking about predictive analytics and streaming is because of data. I told you about those algorithms, right? And when Netflix does their recommendation engine, how did they, remember they put the $1 million contest out a few years ago? Anyone who can prove that recommendation engine by 10%? Now, who do you think won that concert? Was it domain experts? Was it Quentin Tarantino? Was it Robert De Niro? No, it was some mathematicians. Because we have more data, we're more likely to find predictive models, because you can't always find predictive models. So that's another important trend that brings us to streaming analytics as well. And big data simply means all of the data you have at your disposal, and add IoT data to that. And I consider the mobile device an IoT data. Just wanted to quickly show you this slide. We surveyed technology and business decision makers, and you can see that business decision makers, about a third of them are still confused about that term. And for the IT side, about a third think it's an extension of existing analytics and a whole new way of thinking about data. So of course it is. It's an extension of existing and it's a whole new way of thinking about data. But there's still a lot of people confused. And the reason why this is important is because to start to think about how you can use streaming, you have to overcome being obsessed by what big data is or is not. It's all your data. The traditional problem, though, to creating all these analytics is that it's all in silos, which is one of the reasons why we talk about certain big data technologies. And Hadoop certainly isn't one of the only technologies, but it's sort of an exciting one because it's fundamentally it's a file system. So it can store any structured, unstructured, or binary data. Hadoop is also a processing platform. So it can also churn away, run models, machine learning algorithms, queries, whatever you want to do on it. To varying levels of maturity. And that's very good to look through the data, to find predictive models, and to maybe inform human-driven models. But it's too late. It's too late. That analytics is too late for some applications. And there's a lot of live data that's flowing by, and that data may or may not have value. And that's where streaming analytics lives. It lives in that live data and not in the historical data, okay? And so when you think about big data, it's not just about lakes, it's also about this streaming data. And if we look at the difference between lakes and streams, you can see they both ingest and store data from multiple sources. But on the lake side, you're doing analytics that run weekly, daily, or hourly. And then you're going to use those insights to modify future actions. In streaming, you're doing the same thing, but you're immediately feeding that to an application that runs those analytics continuously. And you're mostly interested in second or sub-second responses, but not always. Sometimes it can be a few minutes. But usually streaming applications are in that sub or in the single-digit second response. And those insights are used immediately to proactively adjust immediate and further actions, like detecting that I'm running, so now it's going to start putting in songs that match the tempo of my run. And that brings us to streaming. So we've got predictive analytics, we've got big data that we can create those models, and now we want to execute on those. We want to execute and build apps on those models. Just reminding you that there's a lot of momentum in this area and interest. And our definition of streaming analytics is software that can filter, aggregate, enrich a high throughput of data from multiple and disparate live data sources to do really three things. One of three things, or maybe all of them in some cases. Some people just want to visualize it in real time. But most are interested in detecting those urgent situations. One urgent situation is I start running and they need to stream songs that match my tempo. And streaming applications also automate actions. Okay? They have to automate actions because they're not about generating reports in the future, it's about right now. We call these in-the-moment advantages perishable insights. I think the term speaks for itself. One thing, if you leave here with one thing, do not leave here thinking that streaming analytics is about ingesting high volumes of data. It's not. That's just half of it. Okay? So bear with me. One of the things the streaming analytics platform does is it does have to handle high throughput, peaks and valleys, ingestion, sensor, transaction, any other data that's just flowing. The platforms also have to overcome any architectural concerns. Okay, that's one of the value propositions of these platforms. You don't have to worry about availability, scalability, or latency. And you can connect to multiple sources. So Kinesis, Data Torrent, IBM Streams, all of the streaming products are focused on this. But the real thing that distinguishes a streaming analytics platform is about streaming operators. Everything I just told you before about detecting urgent situations and potentially complex situations doesn't have to do with just taking in data and filtering it. To detect what's happening, you have to have these operators. So sometimes you want to filter the events because not all of the data is important. Sometimes you want to aggregate it. You want to put two streams together. You might want to transform it or enrich it. So for example, one streaming application could be, I have a mobile app, I walk into a mall, and I broke a geofence. That's a streaming application because it's looking at my location. It's streaming in potentially from hundreds of thousands or millions of customers, and it detects an urgent situation, the urgent situation being that I'm now at a mall, and maybe it's putting in weather data and offer data as well, streaming in. And another key characteristic of these operators is that they have windows of dimensionality, so a time window. So think of a deep water pump that has pressure or voltages and currents, and you're taking those in, and you want to know if that's above average over a 10-second period. If it is, that pump may break down. And you also want to do temporal pattern detection. And I'd really like you to think about this one for a second, because you cannot do this with a SQL statement. What if an event A occurred and then an event B occurred within 2 seconds? So any application developers out there, how would you write that code? You can't write a SQL statement to do it in real time. And to write the code to do it is not that easy. I mean, it's pretty easy, but you wouldn't want to do it, right? So the way you'd have to write that code is you'd have to say, whenever an event A comes in, I need to like put it on a stack, push it on a stack. I need to store it. And then I have to wait, in this case, 2 seconds, to see if a B comes in. If 2 seconds passes, I have to dump the A. But if the B comes in anywhere within that window, I have to take it. Streaming analytics platforms that provide operators do that in one simple piece of code or even visually in tools. And that is very, very difficult to do if you're programming. And many people do program it. The other characteristic of streaming applications platforms is they bring in multiple data sources. I talked to a large cable company, right, that has millions of set-top boxes. And they're like, they want to talk about streaming, and they're like, okay, these set-top boxes is output fault codes. A negative number is a fault code. And they just want to know when that fault code occurs, because then they want to proactively call the customer so that they don't have to call. Do you need a streaming application platform for that? Not really. You don't need it, but what if those fault codes weren't so accurate? What if you got a lot of false positives? But what if you got the negative fault code in a 1 minute time period? If you got 5 in a 1 minute time period? That's where a streaming analytics platform would come in, and it would be an easy development to make that happen. So the constructs of streaming applications are pretty easy to understand. There's some very familiar ones, which is filtering data. So you have data coming in, a lot of it is not interesting. There may be other codes. The same cable company records every button press on the remote control and sends it back. And you can imagine they might want to filter out certain button presses and channels. Aggregating and correlating, that's like a join in SQL. And enrichment is where that event comes in. So for example, my device ID comes in when I'm running, and now they want to bring in my customer profile to put in Lady Gaga songs, because that's my preference. The things that you may not be familiar with are location and motion, breaking geofences. Okay, imagine if you wanted to know all the people who went to Walgreens and make them some offer at Walgreens. Okay, and you potentially have millions. That's architecturally, that can be very difficult to do. Streaming analytics platforms make that easy. And I already mentioned time windows and temporal patterns. So most application developers think of this traditional, very simplified traditional architecture, which is the request and response. And that's not just a web architecture, that's a lot of applications, mobile app, web app. You're thinking of what data you need, what data you're pushing, and you're getting it back. The streaming applications you have to think differently, because the data is always coming in. And the streaming analytics platform, once you put a model in there that we covered before, will detect those situations, and very complicated situations too. Now, streaming analytics, I said if you leave with one thing, don't leave that it's not just about ingestion. Ingestion is valuable, and many streaming analytics platforms also populate in analytical, because that data is also valuable for offline analytics. So it's very common. Some people in the industry, has anyone heard of the Lambda architecture? Maybe, yeah, so a few people. That term has been often used to explain this phenomenon of taking the stream in, but then also dumping it to offline analytics. So the way to think about these streaming analytics platforms, it enables a whole new class of applications when you need to detect, adapt, and act on what's happening now. The whole IoT field of sensors and devices, that requires streaming analytics to do anything interesting. These platforms provide development tools to create these streaming applications. I gave you a couple of examples that would be very difficult to program. In the streaming platforms, they have streaming operators that make it very simple to program. And it will these platforms also reduce the development time by simplifying and eliminating any of the architectural concerns. Streaming analytics is not new. It's been done for ages, but people have had to custom program it. So when Amazon released Kinesis, that's why they did it, right? Because a lot of their customers were having to do this custom, and here's a platform that will now do that. So I mentioned IoT because that is also an interesting use case, and I think that's going to make streaming analytics much more interesting. Most applications are really dumb. They have no contextual awareness. And if you think of the mobile device, which I consider an IoT device, I don't separate it, there's a lot of sensors on there. And that contextual information can help you develop apps that figure out what the customer wants next, or figure out what's going to happen next. And so sensors are a big part, or will be a big part, of streaming. So for a lot of web apps, you think of click data, you think of ad clicks and things like that, and other clicks, but there's an increasing number of sensors here. I talked to a mining company. They do coal mines, and they have hundreds of sensors on the mining devices, and they're just sending information back constantly, pressures, temperatures, all kinds of information back. And when one of those machines breaks, they're down for days. They use a streaming analytics platform after they created a predictive model to ingest and then detect those events, and they've saved millions of dollars. So if you have sensors, you probably need a streaming analytics platform. But if you have a mobile app, you probably can use it as well. These are some of the terms that you might hear that also have to do with IoT. All right, so now let's talk about the cloud. The cloud is perfect for streaming analytics because a lot of that data is cloud-born. We talked about the mobile, the web, IoT, but streaming tends to be very peaks and valleys. So the elasticity is really valuable, especially from a cost standpoint, but also just from a scaling standpoint. And streaming never acts alone. It always has to enrich data or talk to another app. So you can have lower latency integration with your application, with your databases. So it's sort of a perfect spot for it. Some of the challenges is that with streaming data, there's a lot of garbage, and you don't know what is good and what is not good. There's still a lot of silos. So you often have to overcome data silos to do the predictive analytics I was talking about, to actually create the models that you can then use for streaming. The large amount of data strains the ability of existing technology to handle it, and most companies simply don't have, or developers for that matter, have a predictive or streaming analytics understanding or background. So they can't even imagine what to do with these things. And there is a lack of external and contextual data sources, but that's changing very rapidly with the Internet of Things. And developers, the biggest hurdle is that developers and business people still think in request and response. They don't think in streams, and that's a real problem. So if you think about how you could create a streaming app, and streaming apps are valuable. They're used for algorithmic trading on Wall Street. They're used for the coal mining company. They're used in car telemetry. So there's a lot of different applications. But if you think about a customer, the type of app you could develop for the customer, what if you could anticipate what that customer wants based upon the contextual information? That's an application for streaming. So streaming analytics can enable 3 different capabilities in apps that you couldn't get without streaming analytics. One of them is content enrichment. So the sensors or other streaming data can enhance that experience of the app. You can do context enrichment as well. And finally, predictive. You can create predictive apps. You can take all of that data in from the sensors, use a predictive model, detect it in real time, and maybe even with that, decide what the user wants. Most apps, users press what they want. What if you could predict in a certain probability what they want to do next? And we're already seeing that in a few apps. A geofencing is a very simple application, a very simple application to understand. It's a location-based application. Streaming can make that really easy. Imagine if you had to code a geofence and then scale that for potentially hundreds of thousands or millions of users. That's no small task. It's a very small task if you use a streaming analytics platform with no architectural concerns. So if you want to do anything with geo, consider a streaming analytics platform. As you know, sensors are going everywhere. The NFL has put sensors in the pads of the player to predict injury. But think about what I said before, right? First, they have to collect all that sensor data. Then they have to do a predictive model. And then they can insert the predictive model in real time. So during the game, they can detect a situation that might be dangerous. There's sensors in law enforcement guns. This sensor determines when the gun is removed from the holster, the direction it's pointed in, and of course, if it fires. That has a lot of implications. Law enforcement would love to know when one of their officers' gun is unholstered, right? That's real time. And another possibility is in retail. So I'm just trying to pique your imagination here. Imagine if you bought a new refrigerator, but you had an old house and you wanted to install the ice maker and the water line. You probably had the experience where you've been to Home Depot or Lowe's like 5 times in the same day, doing some type of repair, you need another tool. You think it's easy, you just buy the copper tubing, but then you realize you need a shutoff valve, and then you realize you need a T-connector to tap the cold water, and you need to hacksaw to put it all together, and finally a drill bit to run the tube to the refrigerator. Now, traditional analytics would produce a report that would be given to the Home Depot executives and would say, look, our customers love us, they come 5 times in one day, right? But what could you do with all of that information in a predictive analytics situation? You could find predictive models that predicted the customer's intent. What is their intent when they check out one or a few items? Are they, excuse me, are they painting the garage? Are they doing a patio? Are they installing an ice maker? Are they fixing a toilet? If you could detect that, if you had a model for that and then could detect it in real time, and this is just one example the self-checkout, you could on that screen put recommendations. Make sure you have this wrench. Make sure you have this. It may already know that you have some of these tools from past purchase history. So that's an example of the type of apps you can create if you start thinking, is there a predictive model I can create to enhance the customer experience? And is there and can I inject that in real time and use streaming data to detect it in real time? So for customer-facing streaming apps, first you have to understand that customer. That's predictive analytics about the customer. Then you have to use streaming data to detect their intent in the moment. And then you have to adapt your app functionality to that intent. That's like a butler. That's like a butler who's like standing quietly behind you, anticipating your need, not in your face, but anticipating your needs, knowing what you want. So think about that when you also think about streaming analytics. Don't just think about, I can ingest all this data and put it in Hadoop and analyze it later. Think about how you can use streaming operators to detect those situations and reimagine how your applications work. And that's the opportunity. I gave you examples of customer and more business-oriented applications like the mining. There's many, many more. And there's a lot of companies doing this. And the speed at which customers expect things and the business expect things, that's why we think that streaming analytics is so interesting to customers. So I would say this, understand, again, that streaming analytics is not just about ingestion, that it's about those operators. Realize that you have to think about predictive models if you want to use streaming analytics in a very interesting way, and then reimagine how you can develop your applications. I do want to talk a little bit about, if anyone, let me put it this way, if anyone has any questions about particular vendor solutions, I'm happy to do that after the session, which is right now. So thank you very much.